So I thought we'd take a look at another linear programming problem that's a little more involved than the couple of variables that we'd seen before. So Better Products manufactures 3 products on 2 different machines. So in this case, we're going to have 3 decision variables, one for each of the 3 products. In a typical week, 40 hours are available on each machine. The profit contribution and production time in hours per unit are as follows. And so we have the profits on the first line, the machine time for machine 1 per unit on the second row of this table, and then down here for machine 2. 2 operators are required for machine 1. Thus, 2 hours of labor must be scheduled for each hour of machine 1 time. So that's an interesting wrinkle. Only 1 operator is required for machine 2. We have a maximum of 100 labor hours available for assignment to the different machines during the coming week. Other production requirements are that product 1 cannot account for more than 50% of all the units produced, and also that product 3 must account for at least 20% of their units produced. So there's some ratio or mix that we're trying to hit because of some other management decisions that are out there. So the question is, how many units of each product should be produced to maximize total profit contribution? What's the weekly profit associated with the solution? And then looking at that same solution, how many hours of production time will be scheduled on each machine? And then some other interesting stuff. What's the value of an additional hour of labor? And then what happens if we increase the labor from 100 hours to 120? Does that change our product mix? Does it change our profit? And are we interested in using that additional 20 hours? So let's try to set this up in Excel. Ideally, you would formulate it first, but I think most of it's rather straightforward, so we might be able to go straight to Excel. So I've gone ahead and started Excel for us, where we have 3 different columns, one for each of the products. So we're doing a product mix again. This time we have 3 variables. So we have 3 columns, product 1, product 2, product 3. I've highlighted in light blue where the decision variables are going to come out. And then the objective function, we can read straight from the table. $30, $50, $20. So 30, 50, 20. And then I've went ahead and pulled out what I think that the constraint should be. There's machine 1 time in hours, machine 2 time in hours, the labor hours, the product 1 no more than 50%, and product 3 at least 20%. So machine 1 time hours, we had a total of 40 hours on that machine, and we want to make sure we stay under it. So I'll put a less than or equal to there to remind us of that. Machine 2 is the same. All right, we had 40 hours of that one as well, need to stay under. So for these first 2 constraints, we can read straight from the table again. Machine 1 time per unit. So it takes a half an hour for product 1, so 0.5, 2 hours for product 2, and 45 minutes for product 3. And the way we make sure we stay under, we're going to use a sum product of our decision variables. Anchor that, make it absolute reference with those coefficients in row 6. So obviously right now it's 0 because these are blank up in the decision variables. Machine 2 time, again we can read straight from the table. We have 1, 1, and 0.5. 1, 1, 0.5. And then I want to copy that down, and it should have done it properly, which it did. Labor hours. So this one's a little more interesting because for every hour that we put on machine 1, we have to double it because there's 2 operators. Every hour that we put on machine 2 is just what that is because it's just one operator. So what we need to do is take 2 times whatever's on machine 1 and add to it what's on machine 2. So we can do 2 times what's on machine 1 plus what's on machine 2. And we see the coefficient for labor hours for product 1 is 2. So think of that as, if I produce product 1, how many hours does it take to do it? Well, it has to go through machine 1. It takes half an hour, but we have to double it because we have 2 operators, so it takes an hour total. Add to it the hour it takes on machine 2, it takes us 2 hours. So we ought to be able to do this. Right? So it takes 5 hours, labor hours for product 2, and a total of 2 labor hours for product 3. And we said we had 100 total labor hours. Yep. So those are the 3 structural constraints that are rather straightforward. The next one is a little more involved. So we want to make sure product 1 does not account for more than 50% of the units produced. So let's I think this one actually might be better if we write it out. So I'm going to maybe make this big. So we're saying, I'm going to write it kind of in words. Product 1 has to be less than or equal to 50% of all the other products. So 50% of all products, not including itself, produced. Alright, so how do I translate this into mathematical notation? So product 1 less than or equal to 0.5 times all of the products that we produce. How do I know how many products I'm producing? It's the decision variables. So it would be product 1 plus product 2 plus product 3. If you formulate it as P1, P2, P3, that's fine too, right? So now we have the mathematical notation or constraint, but we want all of the variables on the left-hand side and a constant on the right-hand side. So product 1 less than or equal to 0.5 times product 1 plus 0.5 times product 2 plus 0.5 times product 3. And then we move all of the variables to the left-hand side. So this will be product 1 minus 0.5 product 1 gives me a 0.5 times product 1. Subtract 0.5 product 2 from both sides. So minus 0.5, 5, not t, product 2. Subtract 0.5 from both sides for product 3. And it'll be less than or equal to what's left on the right hand side is just 0. So we have 0.5, negative 0.5, negative 0.5, less than or equal to 0. So now I ought to be able to 0.5, negative 0.5, negative 0.5, and drag this guy down, less than or equal to 0. Alright. So then the final one was product 3 has to be at least 20% of all products. So we do it very similar to what we did for the other one, which now we want a greater than or equal to, and product 3 will be on the start on the left hand side, and then at least 20%. Is that what it said? 20% or 30%? I don't remember now. At least 20%. All right. So this will be a negative 0.2, negative 0.2, 0.8, and that sum product came through for us. And this would be a 0. Alright, so if you don't understand where this came from, go back and watch this one because it's basically the same thing. And then we need an objective function value. These guys with this. And now we're ready to run it. It's all the structural constraints. We have 5 structural constraints. We have non-negativity, but we can take care of that in the solver dialog. Click on solver. We're maximizing profit, and notice I had cell G2 highlighted or selected when I went in, so it thinks that's what I should do, which is correct. By changing these 3 variables, subject to constraints, we have 4 less than or equal to constraints, so I can add them all in the same statement. And I click add, then I can add another constraint by doing that. So now we have 1 greater than or equal to constraint, which is this guy. Click OK. Make sure that I have non-negativity checked off. Make sure that we pick the correct engine, Simplex LP, because we're doing linear programming. And then click solve. And then this one over here. I want to kick out the sensitivity report. Usually a good idea. Click OK. And so if we go back to our original question, how many of each product should be produced to maximize? So we produce 25 of product 1, none of product 2, and 25 of product 3 for a total weekly profit of $1,250. Right. So that answers that question. How many hours of production time will be scheduled on each machine? So where do I find that? In the left-hand side for those 2 constraints. So I'm currently using 31.25 hours out of the 40. So that's not a binding constraint. Machine 2, I'm only using 37.5 hours out of the 40. So again, that's not binding. It means I have machine time left over. And then it says, what's the value of an additional hour of labor? Well, for that, I need to look at the sensitivity report. First thing, before we move to the sensitivity report, we should notice that labor is the thing that's binding. Right? It's the thing that's, I'm using up all my labor. Even though I have machine time left over, it's the operators that's causing me issue. So if I look at the sensitivity report, I can see I'm willing to pay up to $12.50 for an additional hour of labor, which is the shadow price. Right? So that question is asking me the shadow price. Notice the shadow price on machine time and for both 1 and 2 is 0. I'm not willing to pay anything for it because I'm not using it all. Right? So a value of an additional hour of labor is 12.5. So now the next question is, assume that labor capacity can be increased to 120 hours instead of 100 hours. Develop the optimal product mix, assuming extra hours are made available. What's our product mix look like now? What's our profit? Would you be interested in adding the 20 additional hours? So off the bat, you should say, yeah, it looks like I want labor because that's the thing restricting me. Right? I can make an additional $12.50 for each additional hour that I get in. But notice that the range of feasibility only allows me 6 2/3 more hours. So I know the $12.50 is good for the next 6 2/3 hours. So the question is asking 120 hours. 20 is above that 6 2/3. So I don't know how much. I can't take that 20 and multiply it times 12.5 to figure out how much profit I would get additional. So what that means is I need to change the right hand side of the constraint for labor to 120 and resolve it. So I'm going to copy this just for fun. All right. And then change this to 120. And then I like to zero stuff out, so I'll zero it out, go in, solver, and I should be able to just hit solve because I copied over the worksheet that already was set up. And I'm going to kick out another sensitivity report for fun. All right. So now the product mix changes. Now, before we were not producing anything of product 2. Now we're doing 24, 8, and 16. For a total profit of $1,440. Notice now that we're using up all the machine time as well as the labor time. Right? This number here is 0, right? Negative 1.8 e to the negative 15, so move the decimal over 15 places to the left. That's effectively 0. Right? So now we see that the shadow price for labor is 0 even though I'm using it all up. Okay. Now I have some different shadow prices for machine time because I have used up all the machine time. So I think that answered the last question. Yeah, so would I be interested? Yeah, obviously I would. It raises my profit. Right? So I found a new mix. I had to resolve it because I was outside the range of feasibility. Alright, so I think that's a good example that you can look at and study.